So let's say we're told that a car travels for TL hours on a level road at a speed s sub l. The car also travels for TW hours on a winding road at a speed SW. If the speed of the level road is s sub m miles per hour faster than the speed on the winding road, and the trip is x miles total, what is the speed on the level road? So first what we want to do is go ahead and write down the information we're given. And I already did some of that. I wrote down that we're given that the time spent on the winding road is t sub w, and the time spent on the speed on the winding road is s sub w, and the time spent on the level road is TL, and the time spent on the speed on the level road is s sub l. So that's all these subscripts mean. It's just a kind of a way to help us keep track of which section of the road we're on. So they don't really mean anything. You could actually replace those with other variables entirely if you wanted. But that's just to help me personally keep track of what we're doing. So let's go ahead and write down some other information we're given. So we're also told that the total distance is x miles. And we're told that the car travels s sub m miles per hour faster on the level road than it does on the winding road. So I'll go ahead and write down an equation for that. So we can say that the speed on the level road is equal to s sub m, that should be an m, plus s sub w. So this just tells us that it travels s sub m miles per hour more than it does on the winding road. Okay, so you can also remember that distance is given by the function or the formula s times t, so speed times time. And what we can do is solve for the speed by bringing this time over to the other side. So speed is equal to distance over time. Okay, so what I'm going to do now is I'm going to rewrite our distance that we're given in terms of what we know. So we know that the total trip is x miles, and that's going to be the distance traveled on the level road plus the distance traveled on the winding road. So we know that traveling on both sections, the distance traveled on both sections is going to add up to the total distance traveled. And I'm going to go ahead and rewrite our equation that we're given for the speed. So we're given that s sub l is equal to s m plus SW. Okay, so I'm going to actually rewrite the second equation now as the distance traveled on the level road over the time traveled on the level road is equal to S sub m plus the distance traveled on the winding road over the time traveled on the winding road. So I'm just plugging in this equation right here. Alright, so let's see if we can solve for the distance traveled on the longer road now. So what I'm going to do is I'm going to multiply by TL on both sides. So TL times this, I'm going to multiply this side by TL. And then what we're going to have is that DL is equal to S sub m times TL plus dW over TW times TL. But we're also given, if you remember, that the total distance D traveled is equal to DL plus dW. So now what I'm going to do is I'm going to substitute everything that we have here into this equation. And that's going to give us that D is equal to S sub m T sub L plus D sub W over T sub W times T sub L plus D sub W. And this just is the stuff that we plugged in for the distance traveled on the longer road, or the level road, that is. So then from here, what I can do is I'm going to factor out my d sub w terms. So I'm going to have d is equal to s sub m TL plus d sub w times TL over TW plus 1. So I'm just using the distributive property there, and if you multiply this term through, you should get the same thing that we have up here. So then from there, to solve for dw, first I'm going to subtract this to the other side. So you have d minus s sub m t sub l is equal to dw times TL over TW plus 1. And now finally, to solve for d sub w, I'm going to take this term and I'm going to divide it so we get it over here. So then what we'll have is dw equals d minus s sub m times t sub l all over t sub l over tw plus 1. So it's almost done now. So what's our velocity, or the speed, on the winding road now? So the speed on the winding road is just going to be the distance on the winding road divided by the time spent on the winding road. So plugging that, what we found for dw in, our speed is going to be SW equals d minus sm TL all over TL over TW plus 1, and then that's going to be divided by the time spent on the winding road, so divided by TW. Now this is a pretty ugly expression, so I'm actually going to go ahead and rewrite this as something else. So I'm going to say that S sub W is equal to D minus SM TL all over TL divided by TW plus 1, and that's going to be multiplied by 1 over TW. So then finally, what we'll have is S sub W is equal to D minus S sub M TL all over, and I'm just going to multiply this through over here. So this is all going to be over TW times TL over TW plus TW times 1. So then the time spent on the winding road, or the speed on the winding road, is going to be SW equals D minus SM TL over TL, because these TWs cross out, plus TW. So we're asked, though, to find the speed on the level road, and this is actually the easy part. So we're told that the speed on the level road is equal to the sum speed plus the speed on the winding road. So now we're just going to plug this in here, and we're going to have that the speed of the level road is equal to SM plus D minus SM TL divided by TL plus TW. So this is just the process that we have to use to solve the problems like this, and in the next video I'm going to do an example using actual numbers to kind of see, or to kind of be able to show you how this is applied. So I hope this video was helpful. Go ahead and do me a favor and hit like and subscribe, and I hope you have a great day.